When you want to compare two different groups or two different conditions, but there are the same participants in each group, then you can do a dependent samples or a paired samples t-test. So in this case, in the data set, we're looking for two continuous variables, and the conditions of the independent variable will be in a single column. So for example, in this case, all of these students completed both quiz 1 and quiz 2, which means that we can determine whether participants did better on quiz 1 or on quiz 2. To do this, you go to Analyze, Compare Means, and then Paired Samples t-test. Here, SPSS will give you a box to put the two variables that you're comparing. So I'm just going to put in quiz 1 and quiz 2. You can actually add a number of pairings, so you could do multiple paired samples t-tests at the same time, but for now I'm just going to do quiz 1 and quiz 2. I've covered the options in another video, so I won't cover them here. To run it, you press OK. And SPSS will give you 3 different tables for output. In the first one, it's just telling you basic descriptive statistics for each variable that you inputted. Here we have quiz 1, the average was about 7.5, and for quiz 2, it was about 8. Then it will give you a correlation between those two variables. Because participants completed both variables or both quizzes, then there's likely going to be some sort of correlation between the variables. So this is why SPSS spits out a correlation table automatically. Lastly, we get the actual statistical test that we're looking for, the paired or dependent samples t-test. So to read this, this is our test statistic here at the end of the table. It is minus 2.872. Our degrees of freedom is 104, and our p-value, or the probability of getting this test statistic or more extreme, is 0.005. Because this value is less than 0.05, the test is significant, which means that there's a significant difference between performance on quiz 1 and performance on quiz 2. To report this, you would use 3 decimal places for the t and the p-value, and 2 decimal places for everything else. Because the test is significant, you can go back to the descriptive statistics and interpret what that difference is. So for example, I can look at these values and I can say that participants did significantly better on quiz 2 than they did on quiz 1.